All right, AI is everywhere these days, huh? But sometimes these fancy tools like ChatGPT, they kind of trip up.
Yeah, like they sound so sure of themselves, but then bam, totally wrong information. Or their knowledge is stuck in the past.
Like, come on, AI, catch up.
Yeah.
That's where this whole retrieval augmented generation thing, RA,
Oh,
comes
wow.
in, right?
Exactly. ARI is all about, combining the language skills of these large language models, the LLMs. But then the cool part is it gives them access to outside information, like a whole library they can
Okay,
surf.
so they're not just stuck with what they already know.
Hmm.
That's pretty amazing, but I'm guessing it's more complicated than just like giving them a Google search bar.
Oh, absolutely. It's a whole engineering challenge, which is why this paper we're looking at today is so cool. It's called Seven Failure Points When Engineering a Retrieval Augmented Generation System. It's basically like a roadmap of the traps people fall into when they're building these RA systems.
Ooh, a cautionary tale.
Mhm.
So what kind of sources did they use to come up with these failure points?
Well, they looked at three real-world case studies, like RG systems that are already out there, one for science, one for education, and one for biomedicine.
Wow, so like real life applications. That's pretty serious stuff.
Yeah, and to really push the limits, they did this giant experiment using a massive biomedical data set called BioSQ.
Okay, that's a lot to unpack.
Yeah,
Let's start with the basics.
yeah.
How does our RG system actually work? I'm picturing like algorithms and databases, a whole mess of stuff.
You're not wrong. It's basically a two-step dance, indexing and then querying.
Okay, indexing. So what are we talking, like the back of a textbook?
Kinda. You've got all these documents, research papers, articles, anything you want your AI to learn from. So you break them up into smaller chunks of information and turn them into these things called embeddings.
Embeddings. That sounds pretty technical.
It is a bit. Think of it like a numerical fingerprint for each chunk of text.
Yeah.
It's how the AI captures the meaning.
So it's not just matching words, it's actually understanding the ideas. That's impressive.
Exactly. And how you chunk those documents and what kind of embedding model you use, that all depends on your data and the questions you're expecting.
So there's strategy involved even before the AI part.
Got it.
What about the second step, querying?
That's where the user comes in. So let's say you ask, what are the latest discoveries about dark matter?
Hmm, good question.
Right. The Ariadne system takes that question and also converts it into an embedding, just like those chunks of information. Then it's all about finding the best matches in the database, the ones with the closest fingerprints.
Like a giant matching game, but with like super complex information. And I bet there's a lot that can go wrong.
Oh, yeah. That's where those seven failure points come in. The paper really digs into how these systems can mess up, even when they technically have the right info somewhere in there.
Okay, that's what we're here for. Let's get into those failure points and see what we can learn.
All right, failure points. So the first one, missing content, is like, a classic AI hallucination. The RAG system, it gives you an answer, all confident, like, here you go. But the info, it's not even in the documents it's supposed to be using.
So it's basically making stuff up. Even though it's got all this external info to work with, that seems a little backwards.
Right. It's like one of the big problems with these systems, even with all that extra data, the LLM part of it can still like fall back on its old tricks.
Yeah.
Making things sound good, but, not actually being true.
Okay, so how do you like stop that from happening? More training.
Training is definitely part of it, but you also got to design the system so it knows when it doesn't know something. Instead of just spitting out a made-up answer, it should be like, hey, I couldn't find anything about that. Want me to look somewhere else?
That makes way more sense. It's like setting realistic expectations, right? What about the second failure point, missed top-ranked documents?
Ugh, that's all about the ranking algorithm. Imagine, like, the important info is buried in some footnote of a huge research paper. If the ranking isn't smart enough, it might just skip right over it and focus on stuff that's, less relevant.
So the right info is there, but the system just buries it under a mountain of other stuff. That'd be so annoying.
Super frustrating. It shows how important it is not to just find info, but also to figure out what's actually important. There's a ton of research happening right now on these like smarter ranking algorithms that can do just that.
It's like having superpowers, but not knowing how to use them.
Yeah.
Okay, what's the next og or fail?
Number 3, not in context. That one gets into the whole combining process. Imagine the system finds all these snippets from different places, but when it tries to put them together into an answer, it loses some of the context, or even leaves out key details.
It's like telling a story, but like skipping over important parts.
Yeah. It shows we need better ways to combine all that info while keeping the meaning and context from the original sources.
Man, this is complicated. No wonder these 7 failure points happen so often.
It's a challenge, that's for sure. But that's why this research is so valuable. By understanding where things go wrong, we can make these systems more reliable.
Okay, let's keep going. What about number 4, not extracted?
This one shows, even when LLMs have the right info, sometimes they just don't get it. Like, imagine you ask about some historical event, the system finds the right passage in a history book, but it's written all fancy and academic, and the LLM just can't figure out what the key facts are.
So it's like having all the ingredients but not knowing how to cook.
Exactly. That's where techniques like prompt engineering come in. It's about like guiding the LLM to pull out the important stuff, even from messy text.
We got to teach it to read between the lines.
Yeah.
What about failure point number 5?
This one kind of bugs me. It's called wrong format. Sometimes you need an answer in a specific way, like a table or a list, But the LLM just gives you a big blob of text, like it ignores what you asked for.
Ugh, that would be the worst. Like asking for directions and getting like a whole essay on the history of the roads instead of a simple map.
Right. It's like it doesn't get how humans like to see information.
So how do you fix that? Train it on different formats.
That's part of it, but we also need better ways to control how the LLM gives its answers and make sure it actually fits what the user wants.
It seems like a lot of these failures are about like a mismatch between what the LLM thinks is right and what the user actually needs.
Yeah, that's a good point. And that brings us to number 6, incorrect specificity. This is about finding the right balance, Not too general, not too specific.
Goldilocks and the 3 bears. But for information retrieval, you got to get it just right. But how do you teach that to an AI?
Good question. It's about building techniques that figure out what the user is really after and then tailor the answer. One way is to let the user refine their question, like give more context or tell the system how much detail they want.
So it's more interactive.
Yeah.
Giving the user more control makes sense. All right. What about failure number 7, the final boss?
This one's just called incomplete. The LLM gives you part of the answer but leaves out important bits, even though that info was in the documents it looked at.
Like giving someone directions but forgetting to mention a road is closed, right? They'll get there eventually, but it'll be way more complicated.
Yeah, exactly. It shows how important it is to be thorough when building these systems. Got to make sure the LLM is looking at everything important, not just the obvious stuff.
Wow, this has been a wild ride. It's kind of scary to think about all the ways these RA systems can mess up. But are there any, real-world examples where they're actually working?
Absolutely. That's what makes this paper so cool. It doesn't just point out problems, but also highlights some solutions. They actually talk about 3 case studies where RA systems are doing great things in different areas.
Okay, that's good to hear. Give me some of that optimism. What makes these case studies so successful?
The first one is called Cognitive Reviewer. It helps researchers, scientists, analyze scientific papers. Like, imagine having to read tons of research for your work. This system helps you find what's actually relevant to your question.
So an AI research assistant. Pretty cool.
Right, and it can even answer your questions about the papers directly from the text.
That sounds super useful, especially with new research coming out all the time, like in medicine.
Exactly. The second one is AI Tutor. It's all about education. It hooks into a learning management system and indexes all the course stuff like PDFs, videos, the whole shebang.
AI tutors. That's straight out of science fiction.
It might sound futuristic, but some schools are already using it. Students ask questions, and the AI tutor finds the answers from the course materials.
Wow, that's amazing. What about videos? How does it handle those?
Good question. It uses this speech recognition model, Whisper, to transcribe the videos.
Whisper. That rings a bell.
It's like super advanced. Transcribes audio into text really accurately. Once it's text, it's chunked and indexed just like any other document.
So the AI can basically read videos.
Yeah.
That's wild. And perfect for education.
Totally. And get this, it even has this thing called a rewriter that makes the queries more general. That helps it understand more complex questions from students.
It's like, it's not just about the words, it's about understanding what the student's actually asking.
Exactly. And that leads us to the third case study. This one's all about biomedicine.
That's where getting the info right is super important. What kind of RAGI system are we talking about here?
This one is built on a data set called BioAceQ. Tons of questions and answers, all linked to scientific articles. They used it to, really stress test a RAG system. Thousands of documents and questions to see how well it did.
Sounds like a real trial by fire. What did they learn from that?
One interesting thing was that open source embedding models did just as well as those fancy closed source ones. at least on smaller chunks of text.
So what does that mean, practically speaking?
You don't need to spend a ton of money on proprietary AI models to build good RAG systems.
Hmm.
There are free tools out there that can do the job, especially for smaller pieces of text.
That's great news. But these case studies also show that building a RAG system is just the beginning, right?
Yeah, definitely. You got to keep an eye on it, make sure it stays accurate over time.
What do you mean by that? Like fine-tuning the model as new info comes out?
It's more than just fine-tuning. It's like constantly checking how the system is doing, seeing if any biases or errors are sneaking in, and then adjusting the algorithms or the data as needed.
So it's a constant process, not a one-time thing.
Yep. That's what keeps this field so interesting. It's not just about building something, it's about learning and adapting, pushing what's possible with AI.
I'm feeling way more optimistic now, knowing there are these real-world RAG systems out there doing good work. But before we wrap up this deep dive, I gotta ask, what are the big mysteries left to solve? Where does R go from here?
Ooh, that's a great question. Is what makes this whole REAC thing so exciting. So much we still don't know. Like, one thing I'm really interested in is transparency. Right now, it's kind of hard to tell why a RAG system gives you a specific answer. It's like a black box.
So we need to be able to open it up and see what's going on inside.
Exactly. If we want to really trust these systems, we got to understand how they're thinking. Like, what sources are they using? How are they deciding what evidence is important? How are they getting to that final answer?
Yeah, especially if we're going to use them for serious stuff, medical diagnoses, legal stuff, that kind of thing.
For sure. Another thing I see a lot of potential in is making these systems more human-centered. Right now, they're mostly about giving you, one right answer, but human thinking is way more complicated than that.
So instead of just giving us the answer, we want these systems to help us explore different ideas, help us think for ourselves.
Exactly. We want Rigsy systems that can have a conversation with us, challenge our assumptions, help us think critically about all this information.
Wow, that would be amazing. Like having a personal research assistant that also helps you become a better thinker.
That's a great way to put it. And I think it's the way forward if we want these technologies to actually make a positive impact.
Well, this has been an amazing deep dive into RAG. I started out a little intimidated, but now I'm actually pretty excited about the possibilities.
It's been great chatting about all this with you. It's a fast-moving field, and I can't wait to see what's next for RAG and how it changes the way we interact with information.
Me too. And for everyone listening, thanks for joining us on this journey. If you want more deep dives into AI and how it's changing our world, be sure to subscribe to The Deep Dive. We'll keep bringing you the most insightful analysis and expert perspectives on the technologies that are shaping our future.
Until next time, keep exploring, keep asking questions, and keep learning.
And remember, the future of AI is up to us. Let's make it a good one.